A very good morning to you all, dear students. Welcome to today's physics online class. We have completed three units, as you know. First one is force, motion, and second one is force, and third one is gravitation. In the same line, we are coming into the fourth chapter, and probably this is the last chapter in physics according to the reduced syllabus of ninth standard. This is chapter 11, chapter 11 in your book, Ncert book. This is work and energy. Okay. So we all know this is a very common word. We are using it daily. Okay, work. I worked hard. I work less. I work. I run, and I speak. Everything we do. No, we do something. That is the work. So, for doing the work, we need energy. Without energy, we cannot do any work. So, all living beings need some energy to do work. For example, human beings, what we need food. Okay, with the help of food, the energy is distributed to all our body parts and we do the work. For example, what are the works we are doing? We move from one place to another place, or we sing, we write, we jump, we run, we speak. All is possible only because we have some energy. Without energy, we can't do any work, any action, or any activities. So we need some energy to do all our daily activities, daily works. That energy to us is given by the food we intake. So this is for human beings, so for humans, okay. Animals, do they do work? Yes, they also do work. They move from place to place, they hunt, they run, they jump, they eat. So they also need energy. Even they pull the bullocks, they carry heavy loads. They also need some energy to do the work. Okay, that energy is supplied by the food or what they intake they have. So the human beings and animals, both of them, need some energy to do work. Now, now we are going to understand what is work under the concept of physics. Okay, this is scientific understanding of work, and this is normal understanding of work. What is our normal understanding of work? For example, a particular he is reading, he is writing, all those things. He is browsing through internet. He is reading many books. So, for example, you are preparing for some competitive exams. You did a lot of work. Will that under the work, under the concept of scientific work? No. Okay. According to the scientific notion or according to science, the concept of work is different, and according to a general concept. For example, there is a heavy block of wood or a stone. You are trying to carry or trying to move from one place to another. But you cannot move because it's very huge. You are getting tired. So, for example, if you take such a huge amount of stone and you're pulling it, okay, you cannot move, but you're totally exhausted. You lost all your energy while you're trying to move that particular stone. You lost all energy, but this particular stone has not moved. But conceptually, you worked hard to move it, but it has not moved. So, scientifically, according to the notion of science, there is no work done. But according to you, the work is done. You have spent a lot of energy. You worked hard to move, but it is not moved because it's very heavy. So you have to understand what is work according to science, and according to normal understanding, whatever we do is work. But according to science, what is work? So according to science, I will tell what is work. Okay. For example, if you are playing carom, okay, you are playing carom, sitting here, and you are playing carom. There is a striker, okay. You are applying force on the striker, okay, a striker or any coin for that matter. You are applying force and you are striking it, and this is moving to some distance and it is here. Now the striker is here or here or any place for that matter. Okay. Now, what is work? Okay, you are giving the force and the object has displaced from one point to another point. One point to another point. It has displaced, it has moved from the original position. Okay, this is one example. Okay, this is one example. Second example, for example, if you are going for a or if you're going for a picnic, you will carry a trolley, or if you're going abroad, usually they call trolley. Okay, you are pulling this trolley. Okay, you are pulling this trolley, and for example, from this position, the trolley has moved to this position now. Okay, you are pulling it by force, so the trolley has moved from this position from A to B. Now the work is being done. Okay, this is second example because you are pulling, it has moved from this position to this position. Okay, for example, in a day life, I am carrying a book or I am carrying something like duster. I'm carrying it from this place to this place. This object is moved. So the work is done. Now, what is the scientific concept? After listening to these two examples, what is the scientific concept of work? In these two examples, there are two important things that comes in the understanding of work. What is the two important things? First one is a force. Second one is object or displacement. Let us see displacement. So according to science, what is work? Work is done or work is being done in two important conditions. When a force is applied to an object, for example, this force is applied to the object striker or a coin. The force is applied to this trolley, okay? Trolley. First, first condition, the force should be applied to the object. Second condition, the object must be displaced from one position to another position. Two things, that's all. Only two things. If these two things happen, then the work is done according to science. Okay, now what is the work done? A force is applied to the object, applied on the object, and the object is displaced. If both conditions are satisfied, the work is done. Force is applied, the object is not moved. There is no work done. Okay. Without the application of force, the object is moved. That is also not work done by the person. Okay. So these two are the important things you should know when it comes to work done. Okay, force and displacement of the object must be displaced. Now, for example, cart, okay, or a horse cart or a bullock cart. Now the bullock is pulling the cart, so the work is done. from one position to another position. The bullock is applying the force and the car is moved from one position to another position. Now, work done by a constant force. Okay, work done by a constant force. So, how we can define work according to science? Now, let us see the same concept I am teaching you. This is a table, consider it is a table. Now, this is an object, okay? Force is applied, the application of force, and it is displaced from this position to this position, okay? Now it is here. Now it is here. Okay, this is and this is force, and yes is the displacement. Now, when will you say the work is done? That means when the object be displaced to a distance. So work done is equal to the W. Work done is equal to the product of force into distance or displacement. Force into displacement, that's all. I already said work done has two important things. One is force, another one is displacement. So when is the work done? A force is applied and this particular object A has moved from this position to this position with the displacement S. So force is applied and it is moved to this distance. So work is done. அங்க ஒரு வேலை நடந்திருக்கு. வேலை நடந்திருக்குன்னா we are applying force and it has moved. So the work is done. This is called so W work done is equal to F into S. What is the unit of force? Unit of force is Newton. What is the unit of distance? That is meter. So work done is equal to Newton meter. Newton meter is called joule. Okay. So the unit of work done is joule. Okay. Now when will you say 1 joule? So the definition is very easy. How is the definition? W is equal to Newton meter. When 1 Newton of force is applied, 1 Newton of force is applied to move the object to 1 meter. Okay. Then it is 1 joule. That's all. Simple. Simple. Put everything 1. That is the definition. 1 Newton of force, the amount of force needed to move the object, okay, 1 Newton, to a distance of 1 meter, then the work done is 1 joule. Okay, that is what in the definition. Now you can see. So work done by the force on the object is equal to the magnitude of the force and the distance moved. Okay, so this is called 1 joule. Now when we see, can we do one problem? I will show only one problem or any number of problems, very easy, simply. This is the unit. Work done is equal to force into distance. For example, I am doing the book exercise, first one. Okay, a force of object, a force of 5 Newton is acting on an object. 5 Newton is acting on any object, for example on object. Okay, the object is displaced through 2 meter in the direction 2 meter in the direction of the force. Now force is applied in this direction, the object is moving in the same direction. Now this is applied to this particular condition. When the force is applied in the same direction of the movement of the displacement. Force is applied in the same direction of the displacement. So after 2 meter, the body is moved to this position. Okay. Now, if the force acts on the object in the direction of the force, what is the work done? Simple. Nothing. What is work done? W is equal to F into S. 5 into 2, 10 joule or 10 Newton meter. That's all. Simple. W. This is work done. Now, so today I have only taught what is work done, not anything otherwise. So we are entering into the fourth unit, and these basic concepts you have already did in the fundamentals. I have already said motion, movement, force, distance, displacement, everything we have done. We are again learning new things from the fundamentals. So work and energy, what is the general concept of work? And for the work we need energy. And what is the energy? Energy we will see in the second part of this unit. First we are doing only work. So what is work according to physics or according to science? According to physics or according to science, work is some force is applied on the object and the object is placed to some position, to different position, new position. That is work being done. So work done in the same direction of the force. Okay, the object is moved in the same direction of the force. That we have seen. W is equal to F into S. F is the force, S is the displacement or distance or displacement. Okay, S is distance, but here it is displacement. So we have seen what is work, and the unit of work is Newton meter. F into S, or it is called 1 joule. 1 joule is now is the amount of 1 Newton of force is applied to an object to move an object of from to move the object to distance of 1 meter. Then it is 1 joule. Okay, everything you put 1 then particularly you can come into the definition of joule. Oh, this is what I have taught in this class. If you understand this, do some more problems that is in the book, and understand what is work and what is force and what is displacement, everything. Thank you. Have a nice day.